In this video, we're going to look at two different examples of graphing an exponential function and its asymptote in the form f of x equals a times b to the x. In this first example, we have y equals 4 times 2 to the x power. This 4 out in front is a stretch factor. It's a vertical stretch factor. The 2 is our base. And the asymptote of this function, the asymptote of any function in this form, is going to be at the x-axis. So I'm going to go ahead and put that on my graph to begin with. So my function is going to get infinitesimally close to the x-axis, but it is never, ever, ever going to touch it or cross it. So here's the method that we're going to use to figure this out. We're going to start with x values, and I picked 2 negative, 0, and 2 positive values. We are going to calculate our y values, and we will create ordered pairs x, y. From those, we'll put them on the graph, and we will connect them. So we'll start by plugging in negative 2, and that gives us 4 times 2 to the negative 2 power, which is 4 times 1 over 4, which is 1. If we plug in negative 1, we have 4 times 2 to the negative 1 power, which is 4 times 1/2, which is 2. If we plug in 0, we have 4 times 2 to the 0, which is 4 times 1, which is 4. If we plug in 1, we have 4 times 2 to the first power, which is 4 times 2, which is 8. And if we plug in 2, we have 4 times 2 squared, which is 4 times 4, which is 16. To create our ordered pairs, we have the ordered pair negative 2, 1. We have negative 1, 2. We have 0, 4. We have 1, 8. And we have 2, 16. I'm going to go ahead and put all those on the graph. We have negative 2, 1. We have negative 1, 2, 0, 4, 1, 8, and 2, 16. And the last step is to connect those into our graph. Again, we're going to get really close to that asymptote, but we're never going to cross it or touch it. And there's our graph of y equals 4 times 2 to the x power. For the second example, I'd like you to pause the video here and try to graph 3 times 1/2 to the x power on your own, and then resume the video to see the solution. Welcome back. Let's see how you did. Again, we are going to take our x values that I've identified, 2 negative, 0, and 2 positive values, and we will use those to calculate our y values. If x is negative 2, y is 3 times 1/2 to the negative 2 power, which is 3 times 4, which is 12. If x is negative 1, we have 3 times 1/2 to the negative 1 power, which is 3 times 2, which is 6. If x is 0, we have 3 times 1/2 to the 0 power, which is 3 times 1, or 3. If x is 1, we have 3 times 1/2 to the first power, which is 3 times 1/2, which is 3/2. And if x is 2, we have 3 times 1/2 squared, which is 3 times 1/4, which is 3/4. Let's create our ordered pairs. We have negative 2, 12. We have negative 1, 6, 0, 3, 1, 3/2, and 2, 3/4. Before we put those on our graph, let's get our asymptote on our graph. Any function in this form has an asymptote at the x-axis, so we will put that on. We put it on as a dashed line because it's not actually part of the graph. It's a guideline for our graph. Then we'll put our ordered pairs on. negative 212, negative 1 6, 0 3, 1 3/2, and 2 3/4. The last thing we will do is we will connect all of those points to create our exponential decay curve. As x goes towards infinity, we're going to get closer and closer and closer to that asymptote without crossing it or touching it. And that is the graph of y equals 3 times 1/2 to the x power.